All right, guys, we're looking at section 11.5, the last section in this chapter. So the next day I'll be review and then the test the day after. Make sure if you guys have questions, you're asking questions. I'm getting a few kids asking, but not everybody. So make sure that if you do have questions, you ask. Okay, so we use scale factors and proportions to solve problems involving the perimeters of similar figures. We said that if figures were similar, the ratio of the proportion or the perimeters was the same as the ratio of the sides. Now we're going to take a look at area and how that relates to similar figures. Okay? So here's the idea. If two polygons are similar, in other words, all the corresponding sides are proportional and all the corresponding angles are congruent, then the ratio of the sides, let's say it's FG over AB, the ratio of the areas would then be FG squared over AB squared. Okay? So the ratio of the areas is the scale factor squared. Okay? And so we're going to be solving proportions here ultimately as we go. So it says here that the two figures are similar and that the area of ABCD is 48. So I'll just go ahead and put 48 inside here to remind us that that's the area. Find the area of PQRS. Okay, so the ratio of the sides is 6 over 9 or 9 over 6, however you want to look at that. And we can simplify that. So 2 over 3. So then the ratio of the areas is 2 squared over 3 squared, and then I can set up a proportion, okay? So they went 3 over 2. So that's the ratio of the areas, 9 over 4. So I could say 9 over 4 equals x over 48, and then I could solve, okay? And that's what we're gonna do here. So we end up with about 108 as we go. All right, so why don't you guys give one a shot? It says again that these figures are similar. The area of EFHG is 40, so I'll go ahead and write 40 in there for the area to remind us. Find the area of LMNO. Okay, well the ratio of the corresponding sides, HG to NO, is 4 over 12, which simplifies to 1/3. So that's the scale factor, you guys. The ratio of the areas then is A squared over B squared, so 1 squared over 3 squared. So the ratio of the areas is 1 to 9. Small figure over big figure. The area of the small figure is 40. The area of the big figure is x. If I solve that proportion, I'm going to get the area of the big figure. So 9 times 40 is 360 divided by 1. We should have gotten 360 here. Okay, so again, the area of triangle ABC is 98. So again, I'll write it in here. The area of RTS is 50 this time, so I can go ahead and write that one in. If the figures are similar, find the scale factor and then the value of x. All right, well we know the ratio of the areas is 98 over 50. So if I can get that simplified down to an A over B, right now it's an A squared over B squared, so I have to kind of go backwards to A over B. Then I can set up a proportion. So I'll show you how I would do this by hand and then they'll kind of go through it with you. So I know the ratio of the areas is 98 over 50. I can simplify that. I can divide both by 2 and get 49 over 25. Again, that's the ratio of the areas, which means the scale factor, if this is A squared over B squared, then A over B is the square root of these, okay? So the scale factor is going to be 7 over 5, the square root of 49 over the square root of 25, okay? And then I can set up a proportion to solve. So 7 over 5 equals 14 over x, and we'll see that on the next slide. That part's pretty simple. You guys aren't going to have too much of an issue with that. So this is what I was doing on the previous page. So that's your scale factor. Then we're going to set up a proportion to find that missing x. So 7 over 5 is 14 over x. 14 times 5 divided by 7 is about 10, so x is going to be 10. Okay, and then they're just double checking that those are proportional. So let's do this again. So TUV is 72 for an area, and NOP has 32 for an area. Okay, so first of all, find the scale factor. Well, the ratio of the areas is 72 over 32. If I divide both of those by 8, I've got 9 over 4. And again, that's A squared over B squared because that's the ratio of the areas. So our scale factor is A over B. So the square roots of these are 3 over 2. So that's gonna be my scale factor. Knowing that, I can set up a proportion to find x. So 3 over 2 is gonna equal 9 over x. 9 times 2 is 18. 18 divided by 3 is 6. So if you got 6, give yourself a pat on the back. You're doing a great job. All right, so what about models? Okay, this one we have a little bit of converting to do, so you got to think about this one a little bit more. The area of one side of a skyscraper is 90,000 square feet, and the area of one side of a scale model is 200 square inches. If the skyscraper is 720 feet tall, about how tall is the model? So same kind of thing, you guys. I'm going to find the scale factor like I did on the previous triangles, and then I'm going to set up a proportion using that scale factor. The only thing that throws a monkey wrench in this is square feet and this is square inches, so I do have to convert, okay? And we're going to see them do that here shortly. So initially, we want to convert square inches to square feet, if you will. And remember that a square foot, a foot by a foot, is 12 inches by 12 inches, which is 144 square inches. So 1 square foot is 144 square inches. So if you take 200 divided by 144, you've converted it to square feet, okay? Which is then going to help me find the scale factor, okay? So that 1.389 is what I have for the model, okay? And the area of the skyscraper is 90,000. And that is equal to the scale factor squared, right? That's your a squared over b squared. So if I divide these, I get a really small number, of course. And then I take the square root of that, and I get my scale factor to be about 0.0039. Okay, now I can use that to figure out, okay, we're 720 feet tall, how far are we on the scale model, okay? So 0.0039 is 39 10,000ths, roughly. So then we can say, all right, 39 10,000ths multiplied by 720 will convert it to feet for me, but then I have to multiply by 12 to make it inches. About 33.7 or about 34 inches tall is the model, okay? So why don't I have you guys try one here. The area of one hood of a car is 35 square feet, and the area of the hood in the model is 6 square inches. If the car is 14 feet long, about how long is the model? So you've got 35 square feet. And over here, you've got 6 square inches. Remember though, 144 square inches is 1 square foot. So if I take 6 divided by 144, I get 0.0416 repeating, and then this will be square feet. So 35 square feet over 0.0416 square feet. That's the ratio of the areas. That's your a squared over b squared. So if I take 35 divided by that number, that's 839 points. Well, it's actually 840 if you round here. And that is equal to that k squared, okay? So k is the square root of that number, or about 28.98. Okay, so that's your scale factor. Okay, I have to multiply this by about 30 or so to get up to there. Okay, so how do I do that then? My scale factor, 28.98 over 1, let's say, is going to be 14 feet over x. Okay, so initially then I solve that 14 times 1 divided by that 28.98. I get x to be about 0.483. And what we have to remember is we've converted everything to feet. All of our answers are in inches. Well, I know there's 12 inches in a foot. So if I multiply that by 12, this is equivalent to about 5.8, let's say, inches. Okay, so 5.8 inches is our answer here for B. Okay, so you got to do a little bit of thinking on that one. There's a little bit of converting going on. So pay close attention to this example or the one in the book if you want to do those kinds of problems in homework. And there's your assignment, guys. Page 821, 7 to 21 odd is all. Not too long, so good luck.